What's up guys, it's Simon Fiaz and today's video is on AQA level chemistry multiple choice questions on transition metals. It's been a while since I uploaded a multiple choice question video, so hopefully you guys find it useful. Question 1, which shows the electron configuration of an atom of a transition metal. Transition metal definition, right? An element, I think, with either a partially filled D subshell. Yes, it is that, with a partially filled D subshell in either one of its atoms or ions. D subshell. So I don't care about this, right? Neither do I care about that. These are the only thing I'm looking at. Is that a full 3D subshell? That's empty, so it can't be transition metal. Therefore, it must be B. Because the thing about C and D, they're both full 3D subshells, and therefore they, again, cannot cannot be transition metals because they've got full 3D subshell. If they've got full 3D subshell, empty 3D subshell, can't be transition metal. Question 2, in the table below, which one of the following complex answers are correct? Shape, coordination number, oxidation state. A, linear, yes, that is correct. 2, coordination number, oxidation state, central cation -1. No. B, tetrahedral, 4 -2. Because remember the Cn is Cn minus, right? So that's going to be -2. So therefore, a silver would be +1. C2O4 2 minus, times by 3 -6. So Cr must be +3. But is it octahedral coordination number? No. D, octahedral, yes. 6, yes. +2. Yeah, because remember, that's a neutral. Neutral, and so is that. So none of those have any charges. So therefore, the total oxidation to the metal cation is just +2. Therefore, it is D. Yeah. Question 3a, which will not act as a ligand in the formation of complex ion. Now you need to know your definition for this ligand, right? And once you know your definition, you know it's going to be A. Can't donate A lone pair of electrons. Carbon monoxide can, H2O can, NH3 can. But A, CH4 can only, carbon can only have 4 bonds, you can't donate it, right? Lone pair of electrons. Question 4, which of the following electron configurations that of a transition element? Again, very similar to the first question. Again, just look at the 3D subshells because of the definition. Partially filled 3D subshell. Well, that's full, so that can't be a transition element. That's empty, can't be transition element. That's full, can't be transition element. Therefore, must be B. Question 7, which is not a correct statement. I don't like this because in time pressure you can read it as which is a correct statement. Happened to me before, so what I would do, which is not a correct statement, I just cross it on right, which is false. That's all it means. Which one's false? And that just for me, I find it useful. I don't know if you guys do know. So A, transition metals form colored ions and complexes. That is true, so I don't care about that. That's not going to be my answer. Display variable oxidation state. That's true. Ligand, complex central matter ion with ions surrounded by ligands. Yes, it's C. It doesn't accept a pair of electrons from a transition metal. It donates, and this is why you need to know your definitions to help with your understanding and the overall learning. Memorize definitions. Question 8, which statement is not correct? Again, I don't like this, so I'd say which statement is false. CuCl42 minus is square planar. Well, let's look at the other one. That is definitely octahedral. That is tetrahedral. Square planar, CuCl42 minus, no. Now, my best advice for these kind of questions, familiarize yourself with as much examples of these, memorize the shapes, memorize like all these complexes and designs, learn the shapes as well. And so you can just easily spot it. You don't need to think about it at all. You can just spot them. Question 9, which is the electron configuration C2+. Can't be D, definitely not, because it's got full 3D subshell. And it can't be B, well, full 3D subshell. So it's left with A and C, and remember, loses the 4s electrons before the 3D. So while you draw the electron configuration of copper, draw of copper, or if you memorize it off beforehand, which you probably should have, and then you can just minus 2 and you should get CAR is 3D9. Oh, sorry, yeah, the AR using electron configuration argon. Question 10, which is species given below can behave as ligands. So remember, donates, donor, lone pair donor, right? All three, only NH3, all three, no. That definitely can't behave as ligand. That positive charge, so therefore it's going to be NH2 minus and NH3. NH3 will have a long, yeah, because with the NH4 plus, think about it. Nitrogen positive charge, where this is also called ammonium ion. Where's the lone pair of electrons? It doesn't have it. NH3 though, it does. I mean NH2 minus it does, so therefore NH2 minus and NH3 can behave as ligands. Question 11, which of the one of the following could not act as a ligand? So again, your definition comes to use, memorizing definition. F minus, CH3, CH3, NH2, NH2, CH3, O, CH3. This one, F minus, yeah, that definitely can. NH2, NH2, well, that will have the lone pair of electrons. CH3O, CH3. Again, remember with the mechanism then, it will have a lone pair of electrons. It's going to be B, CH3. And the reason it's going to be B, and I should have spotted it earlier, is because carbon can only form 4 bonds max, right? And that's what it's done. It's got 3 hydrogen bonded carbon and a methyl group. So therefore that's it. It can't act as a ligand, it can't, and it's got no pair of electrons, it can't do it. So I should have spotted that quick earlier, but yeah, B, CH3, CH3 cannot act as a ligand. That's the end of multiple choice questions.